My name is Luke, and I'm a member of Team Kajima for the course CEE 420 at the University of Illinois at Urbana-Champaign. Today, my group and I will be presenting our term project for the course. For this project, we were to analyze the construction process for an ongoing project and develop 3 alternatives to try and increase the productivity of that process. During the presentation, I will first give a brief introduction to the project site that we chose. Then I will hand it off to the other members of our group to discuss the area of study and site conditions, as well as our methods used to analyze the existing process and our proposed improvements. We will then show how much each alternate will cost and finally give our conclusions. The site we chose for our analysis is the construction of a new luxury condominium tower in Scottsdale, Arizona. We chose this site because it had a live webcam video feed available that we could view online. This allowed us to remain as safe as possible since it did not require that our group be present on a live construction site. Currently, construction crews are installing wood framing for the walls of the individual condominiums, and this would be the process that is the main focus of our productivity improvement analysis.
The specific activity under study is the assembly process for the wooden panels for the structure. The wooden panels are built on the ground and then lifted up using manpower. The activity is broken down into transportation of the lumber, aligning and positioning the individual pieces of wood, nailing, lifting the panel, and fastening the panel vertically. There are a total of 5 workers and a forklift involved in the activity. One person is constantly moving lumber from the pile to the laydown area. The 4 other men are positioning, aligning, and nailing the panel. Once the panel is ready, the panel is lifted up by all 5 workers, and one of the 5 workers lets go of the panel and fastens it to the rest of the structure using a nail gun.
Hello, my name is JAIMES, and I'm here to talk a little bit about the job site. This project is located in Arizona and is normally very hot. It's very dry, it's very sunny. There's also no shade on almost the entire job site, and we note that this can affect productivity, but we're doing the best that we can. There's ample space on this site for materials and storage, and because it's still early in the construction phase, it is very open, and that's where they're being stored. There are many stacks of wood panels which are being used to construct wooden frames, and they are placed a few meters away from where they are actually being used by the workers. There's also 2 concrete elevator shafts that have been erected and are placed opposite each other on the job site on the east and west end. A few forklifts on the site are being used to transport wood from where they're being stored in the open area to where they are being used by the workers. There are also a lot of materials that are not being used at the moment, and such as extra wood panels and some metal frames. These are stored kind of off center in order to have them away from where the main work area. Some of these materials are covered or uncovered depending on whether or not they're being used at the moment. There are currently 7 workers in the main area, and they are erecting wooden frames, and there are also a few workers who are towards the back of the site who are doing the same. Thank you.
In order to analyze productivity of sites, crew balance charts were created. A crew balance chart is a diagram representing characteristics of each activity, of each entity on site. A crew balance chart is a breakdown of activities for one cycle of production. It is separated into various sections, and then these sections are combined to form one cycle of production on site. Crew balance charts are similar to vertical bar charts, where the bars are vertically divided into time intervals. These subdivisions are plotted on the same time scale in order to relate all these activities. Idle times are blackened out to show areas of inefficiencies. Crew balance charts are extremely important for construction study, as they can optimize efficiency levels by deleting as much idle time as possible. This helps corporations to be as fast and productive as they possibly can.
A process chart represents a step-by-step instruction of all activities required to complete a cycle. It includes a list of symbols representing typical construction activities such as transportation, operation, inspection, delay, and storage. It is set up as a vertical list of symbols with corresponding specific activities listed next to them. A flow diagram represents an operation through a line sketch, which shows movements of people and machinery. Process charts and flow diagrams are usually paired to define a construction activity clearly, in a step-by-step instructional manner.
The wood framing technique used on this project is a fairly standard process. The current process involves 5 laborers and a forklift to install wood stud framing. The site has plenty of laydown area, and the workers are able to navigate the site freely with very few obstructions. The two materials needed for this process are nails and lumber. The forklift is in constant use for this process, transporting materials, primarily stacks of lumber, from the laydown area to the work area. One of the workers is responsible for transporting lumber from the forklift to the raised concrete work area. After the lumber reaches the work area, the other 4 laborers assemble it into a frame. Once the 2 frames are constructed, all 4 laborers raise the first frame into place. 3 of the laborers position the frame in place, while the 4th laborer vertically fastens it. The same procedure is followed for the second frame. At this point, the cycle is complete and starts over, averaging a 15-minute duration and 80 square feet of framing. This process produces roughly 64 square foot of framing per man-hour, with a unit labor cost of $0.133 per square foot of framing. Throughout the whole process, the only tools that are used are a hammer to nail the wood, a carpenter's square to ensure correct alignment, as well as a level to verify alignment. It is assumed that the laborers are using hammers to do the nailing, since there is no compressor within view of the active constructive site. A water jug is kept nearby to keep workers hydrated to reduce fatigue and keep productivity high. This framing process is fairly standard, although it does leave some room for improvement. All 5 laborers have idle periods within the cycle, which signifies that this process is inefficient and can potentially be optimized to increase productivity. Both the worker transporting the material and the worker positioning the wood have periods of idleness in between their construction actions. The 3 workers who are nailing the frames together also experience a period of idleness at the beginning of the cycle. Both of these idle periods represent inefficiency in the current process. Of the 7 activities in the process, 4 can be shared and therefore are time-dependent on the amount of laborers engaged in the activity. These 4 activities include lifting the frame, vertically fastening the frame, aligning, and nailing. One of the problems with this process is the location of the materials. 1 laborer and 1 forklift are in near constant use, simply transporting the lumber from one part of the site to another. This appears inefficient considering the volume of laydown space available around the building area. Another inefficiency is the equipment used. A nail gun or other air tool could potentially speed up the process and require less laborers than the traditional use of hammers. Overall, the process used for the wood framing of this project is adequate, but it could be significantly optimized, increase productivity, and reduce worker fatigue.
We're talking about the new improved crew balance Plan 1. In this plan, a new laborer will be added to the crew in order to help spread out the work and speed up the process as a result. Laborer 1 will now do more than just transport the wood. He will now help with the other areas of this process by helping fastening, nailing, and lifting of the frame. Laborer 2 will still be positioning wood, but he will also be involved in the nailing, lifting, and fastening of the frame as well. Laborers 3 through 6 will all do the same task for almost the whole time. They will now help with the aligning, the nailing, the lifting of the frame, holding the frame, and fastening. This new crew will be asked if they are comfortable lifting the frame as a group of 3 instead of a group of 4. It is important to note that this makes it easier on the whole crew since the work is more spread out, and that the extra worker will be able to help other areas of the process. A big difference is that the forklift will be idle for a longer time. It is suggested that this forklift help other crews during this idle time or transport the wood continuously, acting as a separate crew. In addition, laborers 1 through 3 can help switch roles with 3 through 6 so that the same 3 people are not lifting the frame as a group 3 for the whole time. This helps put less strain on the entire crew as they are switching with the most strenuous task. Overall, this will help because it gives the same amount of work in a short time, but also puts less strain on the laborers, as I said before. The productivity of this new plan is 66.67 square feet per man hour, which is slightly higher than the 64.0 square feet per man hour of the original plan. The labor unit cost of this is $0.10625 per square foot, which is lower than the original of $0.1328 per square foot. In addition, this is also the lowest labor unit cost of all plans, including the original.
From the original plan, we took away Laborer 3 and added his tasks primarily to Laborer 2's assigned tasks. We assumed that having 4 people is not necessary to lift the frame and that having 3 people is sufficient. Comparing the original crew balance to the new improvement plan's crew balance, one can see that the chart does not change very much.
With our improvement, the time per cycle increased by 30 seconds, making the entire cycle time to be 15 minutes and 30 seconds. The productivity calculation increased significantly, with a 13.4 square foot per man hour increase to 77.4 square foot per man hour. Additionally, the labor unit cost increased slightly from 13.3 cents per square footage to 13.7 cents per square footage.
Plan D represents a choice of improvements to remove 2 laborers while having 1 forklift. This is done to relieve idle time and maximize efficiency. The improvement resulted in an increase in cycle time from 15 minutes to 22.5 minutes, an increased labor cost from $0.13 to $0.2 per square foot, and an increased productivity from 64 square foot per man-hour to 71 square foot per man-hour.
Although this solution was not as efficient as the other 2 improvements, it is still an improvement of the initial division of activities. The removal of 2 workers resulted in an increase in labor unit cost of approximately 50% due to a nearly doubled cycle time. Regardless, we still see an improvement in the productivity of approximately 10%. Hence, although this solution is the least favorable of the 3 propositions, it is still a good improvement.
The implementation plan is essentially the same for each new plan. The only difference is the amount of laborers. For the first plan, we would have to bring a new laborer to the job site. For the second plan, we would have to relocate laborer 3 to a new job site. And for the third plan, we would have to relocate laborers 4 and 5 to a new job site. For each new site, we would have to explain the process to the crew, show the crew the new balance chart, go to the site with the crew and test the new process to make sure everyone understands, test the assumption that 3 people is sufficient to lift the frame, and film the new process to create a crew balance chart to see if there's a productivity improvement. Costs are also calculated based on RS means cost data. Based on this data, each labor is $26.45 per hour, forklift rental is $17.41 per labor hour, the equipment operator is $33.55 per hour, and the wood bracing is $635 per 19.77 labor hours. Overall, this means $48.52 per cycle for Plan 1, $49.01 per cycle for Plan 2, and $51.96 per cycle for Plan 3.
Based on the analysis of the existing construction process and the proposed improvements, Plan 1 will be the most productive. Even though this plan requires 1 more construction crew member, that additional member will increase the number of wall units constructed per hour by 1 and reduce the construction cost per square yard by $0.03 per hour. By decreasing the number of construction crew members, the amount of time required to construct wall units increases slightly, but the offsetting costs for fewer crew members does not result in increasing productivity nor cut costs. Even though implementing Plan 1 may not seem like a huge cost savings, applying these savings to a large multi-story condominium can really start to add up to the contractor. It can also be noted that as the construction process of condominium continues, the construction crew will get more acclimated to the process and increase the productivity and savings even further. By calculating crew balance charts and drawing process charts and flow diagrams, the contractor can really get a better understanding of how to utilize their crew members and equipment in a more productive way.